So what we're going to do now is look at Mealy machines versus Moore machines. We just want to look at this because there is a difference between these two things, and if you go online and start looking up state machines, finite state machines, you're going to see examples of both Mealy and Moore. What we're going to do in class is only Moore machines, but you need to know the differences so that way if you run across it with other resources, you're not confused. So with that, let's just jump in. Let's look at what a Mealy machine is first, and then we'll look at the Moore machine. A Mealy machine is just a state diagram or a state machine that has both inputs and outputs. You'll notice that the outputs depend on both the state and the input. For instance, whenever I leave state 2, if I go to state 1, my outputs are going to change in one direction, and if I leave to go to state 3, my outputs are going to change a different way. So it matters how I leave that state. Also, it matters how you get to that state. For instance, if you get to state 1, if you get there from state 2, you might have one set of outputs, but if you get to state 1 from state 3, you'll have a different set of outputs. So they're different. And that is what a Mealy machine does. You can see it in the block diagram here. What this block diagram is saying is that your inputs and your current state, so this is combinational logic, so your inputs and then your current state, that's memory right there, feedback in here to determine not only what your next state is going to be, but also what your combinational logic is going to be. I mean, your outputs are going to be based on a little bit more combinational logic. So your outputs are based on both memory and inputs. So the current state and the inputs determine your outputs. That is the big difference between that and a Moore machine. A Moore machine does not care how you got to that state. As long as you're in state 1, these are the outputs. It doesn't care if you came from state 2 or state 3. As long as you're in state 1, these are your outputs. And you can see that in the block diagram. Here, the outputs are only a function of the current state. It is not a function of the inputs. And that's the big difference. This is what we're going to stick with the Moore machines in class. One other thing, and that is the fact that we have been calling our states A, B, C, or 1, 2, 3, or washer on, washer off, washer rinse, or whatever. But those are not useful whenever we actually go to solve the circuit. What we want to do is we want to use values Q1, Q0. And that is referencing our flip-flops. We'll have flip-flop 1 and flip-flop 0, so that your inputs are, your states are going to be state 0, 0, state 0, 1, state 1, 0, and state 1, 1. All right, and that's all that I want to do in this short video. What we're going to do in the next video is actually take a Moore machine and step through a full example of how you go from a state diagram to a completed circuit. And that will be next.